Okay, in today's lesson, we're going to look at another property of triangles, and that is a line tangent to a triangle. So, let's just jump into it. A line is tangent to a circle if the line touches the circle at only one point. So in the picture to the right, line AB is tangent to circle O at point P. Now, one fallout from being tangent: if a line is tangent to a circle, the line forms a 90-degree or right angle with the radius of this circle. So that's going to be the key concept that we're going to look at today. We're going to use that to find the measure of some angles, but we're also going to use that in conjunction with the Pythagorean theorem to see if a line is indeed tangent to a circle. And second, two tangents from one external point. If from one external point, and they're talking about point C here, that's an external point, two tangents are drawn to the circle, then they have equal tangent segments. So these two line segments are congruent. Tangent segments mean lines joining to this external point and the line of tangency. Consider the following diagram. So again, we have two congruent segments that are tangent. The two radii of course, are always tangent, and those tangents meet the radii at a 90-degree or right angle. So we have four examples and start to take a look at it. Example 1. Determine whether segment BC is tangent to circle A in the diagram shown. So for segment BC to be tangent to the circle, we know it has to form a 90-degree angle with the radius. For it to form a 90-degree angle, it would make a right triangle, which means it would satisfy the Pythagorean theorem. Now, if you recall, the Pythagorean theorem is the sum of the squares of the two legs is equal to the square of the hypotenuse, or a squared plus b squared equals c squared. Now, a and b can be arbitrary, but they have to be two of the legs. I'll call 9a and 40b. The hypotenuse, the side that you want to be across from the 90-degree angle, always has to be the hypotenuse. So let's see if this is true. I have 9 squared plus 40 squared equals 41 squared. Now, I know 9 squared is 81. I know 40 squared is 1600. And I know 41 squared is 1681. If you don't know that, you can just do it in your calculator. But if you add these two up, 1600 plus 81 is 1681. So you have 1681 equals 1681. This checks out. Therefore, BC, segment BC, is tangent to circle A. If I didn't get these two sides to be equal, then it wouldn't be a right triangle. Therefore, it would not be tangent. Okay. Let's move on to the next example. Example 2. Each side of triangle ABC is tangent to circle O at points D, C, and F. Find the perimeter of triangle ABC. Alright, so triangle ABC is the big triangle. Now I know this segment, this whole bottom segment, and I know this segment, so I have to figure out the rest. Well, using the second theorem that we saw, two tangents from an external point, if this side is 7, then this line segment also is 7. By that same idea, if I look at the bottom, if this side is 5, then this segment is also 5. Now, if this entire bottom side, BC, is 16, and segment BE is 5, segment EC is 16 minus 5, which is 11. And again, by that, last theorem, if this bottom segment is 11, Segment CF is also 11. So I know my bottom side is 16. I know this side, 7 plus 5 is 12. And I know this side, 7 and 11 is 18. So my perimeter is, what do I have here? 12, 18, and 16. 12 and 18 is 30, and 16 is 46. So the perimeter of the triangle is 46. Moving on. A landscaper wants to build a walkway tangent to a circular park as shown in the diagram. Okay, so I'm assuming this is the walkway. The other walkway pictured, oh, I'm sorry, so I guess I want one tangent, so I want one like that. The other walkway is pictured as a radius of the circle and has a slope of -1/2. So let me change my color here. For my red line segment, my slope is -1/2. If the walkways should intersect at the point 4, 2, or I'm sorry, 4, -2, right there, what equation can the landscaper use to graph the new walkway? Okay, so I want an equation for the blue walkway. Well, a couple things. If this forms a 90-degree angle, if we remember back to Math 1 and Math 2, the slopes of perpendicular lines are opposite reciprocals of each other. So if the slope of the red walkway is -1/2, the slope of the blue walkway is a +2/1, or just 2. Now to write the equation of the line, I can use point slope form, and as a reminder, point slope form is y minus y1 equals m times x minus x1. Now I know my slope is 2, so I'll put a 2 in for m. My coordinates are 4 for x and -2 for my y. So I'm going to clean this up. Y minus a -2 is y plus 2, and 2 times x minus 4 is 2x minus 8. I'm going to subtract 2 from both sides, and I am going to get the equation of the blue sidewalk to be y equals 2x minus 10. So that one has a lot of recall from both Math 1 and Math 2. All right, our last example. AB is tangent to circle C at point B. So now I know there's a 90-degree angle. Find the length of segment AB, we'll put a question mark there, as well as the measure of arc BD. Okay, there's a lot of stuff going down here. Well, I guess first I'm going to call this, instead of a question mark, I'm going to call this A. So let's find the length of A first. So again, that's a right triangle, so I know A squared plus B squared equals C squared. A is my missing side, B is the leg that's given side 8, and C is 17. So to solve this, I'm simply going to square 8, which is 64, and 17, which is 289. And I'm going to subtract 64 from both sides, and I'm going to get 225. And then to solve for A, I'm going to take the square root because it's the inverse operation of squaring. And what I get is 15. So side A is 15. Now, find the measure of arc BD. Let's see. If this angle is, let me switch colors here. If this angle is 28 and I have a 90-degree angle, I know this angle, I'm going to show my work down there, is 180 minus 90 minus 28. All right? So I get this angle to be 62 degrees. So I have 62 degrees. Now, the measure of arc BD subtends the central angle, therefore it has the same measure as that central angle. I'm going to switch colors again. Let's go orange here. So I know that the measure of my central angle is 180 minus that 62, because these lie along the diameter, which is a half a circle, which is 62, and 180 minus 62 is 118. So this arc is also 118 degrees. So it's kind of the same game as the rest. You just have to play with what you know and find out what you don't. Thank you.